In this class, we are going to discuss about the single phase of a control rectifier circuit with a RLE load. RLE load is nothing but a armature of a DC motor. Now, to explain the circuit operation, we have taken the input voltage pi, 2 pi, 3 pi, 4 pi. We are applying the triggering voltage to the SCR whenever it is a forward bias alpha 2 pi plus alpha. We start developing the output voltage waveform. 0 to alpha no device connecting circuit, so the output voltage becomes 0. After alpha, SCR is on. Once the SCR is on, the voltage across the RLE load is equal to the input voltage up to beta. This SCR is forced to conduct after the pi because of the inductance. At a beta, the current is coming to the 0, so the SCR is off. Once the SCR is off, there is no connection between the load and the source. But in case of RLE load, the load is connected to the E. So the output voltage becomes a E from beta to 2 pi plus alpha. Again at 2 pi plus alpha, SCR is on. Once the SCR is on, the load voltage equal to source voltage up to 2 pi plus beta. After 2 pi plus beta, again SCR is off. Now the load voltage equal to the voltage in a load, that is E. If we draw the output current waveform, the current is starting from alpha, it reaches the maximum value at pi and come to the 0 at beta. From beta to 2 pi plus alpha, no device is connected in circuit. Even though load is subject to voltage, but it is open, so the current becomes a 0. Again from the 2 pi plus alpha, the current is increasing maximum value. After that, it is come to the 0 at a 2 pi plus. If you find the average output voltage, the base length becomes a 2 pi. Now you have to find out the area under the curve from alpha to 2 pi plus alpha. 1 by 2 pi integral alpha to beta Vm sin omega t d omega t. It gives the area under the curve up to alpha to beta. Now you have to find out this rectangular area. That we can get it. This length becomes a 2 pi plus alpha minus beta into E. So this is representing the area of this rectangle. Now this quantity we are adding to the integral part whole divided by 2 pi. If we simplify this one, we are getting this expression. Now we are going to keep this circuit operation in a table form. Alpha to beta, SCR is conducting, the output voltage becomes a VAB. Beta to 2 pi plus alpha, no device is conducting, so the output voltage becomes a E. 2 pi plus alpha to 2 pi plus beta, again SCR is conducting, the output voltage becomes a VAB. So thank you very much for watching this video.